Good morning everyone. Today in this video I'll be talking about site directed mutagenesis, which is another very important technique under directed evolution method. Remember, I have already mentioned about the brute force mutation and how to overcome the disadvantages of the brute force mutation. Site directed mutagenesis is the answer. So site directed mutagenesis is basically it will specifically mutate the gene of interest. Okay, it will specifically mutate the gene of interest. How? There is a process. It's a long process, but it's a very interesting thing. First thing, that is, it will start with, suppose you have the gene of interest. It looks like this, and that has a sequence. What is the sequence? A T G A C C T A. Okay, suppose this is a sequence of your gene of interest. This is the gene of interest, this total thing. Okay, starting from here to here. This gene of interest now cloned into, I should use another marker to make you guys understand, another thing, that is plasmid. Okay, so clone this part of gene of interest into a plasmid. This is a plasmid. Now this total cloned plasmid will be introduced into the microbes. It can be bacteria, it can be yeast, industrially important microbes. Okay, after that, in the meantime, you need to prepare a sequence which is basically a primer. In a simple words, it's a primer. So what is the function of a primer? The primer will basically anneal to this thing. Okay, and after the cycles of the PCR, this product will be generated. How? Another thing, there's a condition. This gene of interest, this part has methylation at its base pairs, not base pairs, at its bases. Okay, or only a single base that can be methylated. So this is the total thing, a plasmid that has the gene of interest cloned into this, and that plasmid will be introduced into the microorganism used in the industry to produce either wine or antibiotic or something else. Okay, now you need to prepare what I have already mentioned, the primer. How the primer looks like? Obviously the primer will be just have the complementary sequence of this sequence, but there will be a single change in their nucleotide. So you need the primer. How the primer looks like? All the other things will be same, but there will be change in a single nucleotide base. There will be change in a single nucleotide base. Okay, there will be change in a single nucleotide base. Now this primer part, that will be complementary to this sequence. Okay, and in the successful PCR reaction, from this primer, after it will annealing it in this sequence, it will give rise to another DNA sequences. Okay, how? First the primer will anneal to this. How it looks like? First, this one is the sequence, gene of interest. Okay, this one will anneal to this. How? T A See, now look at here. I have already mentioned there will be change or modification in a single base of the primer, which will not anneal here at the gene of interest sequence. So it will not anneal. Obviously, G will never bind or base pair with adenine. So how it looks like? It looks like this. Now rest of the other parts will anneal to this one in this way. Okay, so this thing will be annealed like this. So primer annealing done. This is the plasmid. Okay, this is the plasmid thing. Now during PCR, what happens? A new strand will be generated. Okay, already primer has annealed with the gene of interest sequence. What I'm saying, a new strand will be generated by seeing this parental strand. A new strand will be generated by seeing the parental strand. So this is the new strand. Okay, generating from the parental strand after annealing this primer to the gene of interest sequence. Okay, so in this way, the successive rounds of PCR reaction, it will give rise to a huge amount of PCR amplified product, which has this new strain has been made from the old parental strain of the plasmid after seeing this gene of interest sequence. Okay, so this is basically the site directed mutagenesis technique. Site directed means you are directed to a specific site of a nucleotide stretch to be modified so that it can modify those gene of interests, okay, to produce a specific or your product of interest like penicillin. If you want to increase the production amount of penicillin or any kind of a wine producing yeast, okay, so you have to just modify a single base, nucleotide base in your primer sequence that will not gonna anneal to the gene of interest sequence. And with this there is a methylation in the parental strand, and with this new modification, what happens, a new DNA strand will be produced, and huge number of copies of this gene of interest will be produced with the help of PCR method. Okay, so in this way site directed mutagenesis works. And after that, what happens, nuclease that will be applied. Okay, nuclease will be applied which will cut this parental strand only. Application of a nuclease specific to cut this parental strand. Okay, and this will give rise to only this. Suppose if you don't have this parental strain, okay, so you only have this newly synthesized strands. So in this way site directed mutagenesis works, which will specifically modify a gene of interest to produce the interested product in the industry and help in the industrial microbiology. Thank you so much. If you like, please subscribe my channel and share with your friends.